This week at NASA. A NASA-sponsored mission in Alaska is exploring how changes in the Arctic sea ice cover may be contributing to global warming. IceScape, for impacts of climate on ecosystems and chemistry of the Arctic-Pacific environment, is working its way through the Bering Strait, headed for the Chukchi and Beaufort Seas. For the next few weeks, biologists and biogeochemists aboard a high-tech icebreaker called the Healy will study ocean and sea ice samples for their physical, chemical, and biological characteristics.
First, we're going to be measuring how thick the ice is. We'll be doing surveys along to see the variability in the ice thickness, and then we'll also be looking at how sunlight interacts with that ice cover. What we'll be doing is measuring how much sunlight reaches the surface, how much of that sunlight is reflected from the surface, how much sunlight is absorbed in the ice, and how much is transmitted into the ocean.
Scientists want to determine how changes in the polar region may inhibit the ocean's ability to absorb carbon from the atmosphere. The greenhouse gas carbon dioxide is a leading cause of global warming. It was the first satellite of its kind, able to relay commands, navigate, receive data, and allow ground controllers to talk with space shuttle crews in orbit. Now, after years of continuous service to more than a dozen missions, NASA's tracking and data relay satellite, TDRS-1, is retiring.
And liftoff of the Orbiter Challenger and the sixth flight of the Space Shuttle.
We have a go for deploy.
Launched with Shuttle Challenger on the orbiter's maiden voyage in 1983, TDRS-1 began NASA's move from a gap-filled system of ground-based stations to a space communications network with 24/7 capabilities.
When TDRS went up, it was for the shuttle, and so the shuttle was really the first mission to use it. And so eventually we had Earth science missions and space science missions, and obviously I think the most famous is what we do with Hubble today, that uses the TDRS spacecraft to relay all its marvelous pictures of the heavens.
Among other successes, TDRS-1 was the first satellite used to support launches from the Kennedy Space Center in Florida in the early 1990s. And it relayed the first phone call between the South and North Poles.
When TDRS became a daily service for the National Science Foundation team at the South Pole, they set up their day around when TDRS F1 was available, normally about 5 to 6 hours a day, so that they could do their emails, send files, receive information, communicate with, with their families and loved ones. So it was, for them, it was an absolute game changer.
And literally the South Pole Station's lifeline. During a highly publicized medical emergency there in 1999, U.S. doctors used TDRS-1 high-speed connectivity to assist weather-stranded scientist Jerry Nielsen through her own breast biopsy and chemotherapy. TDRS-1 arrived at its final destination about 22,500 miles above the Earth on June 13th and will be shut down this week to begin the updating of NASA's TDRS suite of 9 satellites.
Saying goodbye to a friend who has served the nation well, but there'll be more friends that will come along when we launch the next generation of TDRS spacecraft.
3, 2, 1, launch. Stop.
The replica Orion crew module used in the highly successful launch abort system Pad Abort 1 flight test in New Mexico May 6th has returned to the Dryden Flight Research Center. The crew module and its separation ring were airlifted back to Dryden from Holloman Air Force Base near the White Sands Missile Range test site. Dryden engineers and technicians will spend several months inspecting the module and all of its systems for possible use in another abort flight test. The Glenn Research Center, Plum Brook Station, and the Marshall Space Flight Center welcomed members of the STS-131 crew to share highlights from their recent 15-day mission to the International Space Station. In April, the 7-member crew aboard Shuttle Discovery ferried to the complex a number of projects overseen by Glenn and Marshall, including 4 space experiments designed, fabricated, tested, and managed by Glenn, and a multi-purpose logistics module containing the Window Observational Research Facility, or WARF, an Earth Science Observatory rack under Marshall's charge.
We get the honor privilege of going to fly it in space, but without the thousands and thousands of people here and around the country working on the space shuttle program, it would not be a success like it is today.
Commander Alan Poindexter led the STS-131 mission, and Jim Dutton served as the pilot. Mission specialists were Rick Mastracchio, Clay Anderson, Dottie Metcalf-Lindenberg, Stephanie Wilson, and Japan Aerospace Exploration Agency astronaut Naoko Yamazaki. STS-131 was the 33rd space shuttle mission to the ISS. While soccer fans around the world watch and await the winner of the 2010 World Cup, student players from the US and Canada heard scientists and engineers from the Ames Research Center's Fluid Dynamics Laboratory explain the aerodynamics of the Jabulani soccer ball. Specially designed for this year's tournament, the Jabulani, which means celebration in Zulu, has come under criticism from World Cup goalkeepers who claim the ball can be unpredictable in flight. During a special presentation, professional soccer player Stephen Bidashar of the San Jose Earthquakes helped a NASA physicist identify the reason for the ball's flightiness, an aerodynamic principle called the knuckle.
You can see here, just from the trail, how the ball changes direction as it's flying away from us. And that's what the knuckling effect is. And with the smoother balls, that critical speed at which this knuckling occurs is increased, and that's why you're seeing more of it.
The event was part of a NASA Long Distance Learning Network webcast. And that's This Week at NASA. For more on these and other stories, log on to www.nasa.gov.